Hi there and welcome to part 8 of our project to build a radical new synthesizer. And just to refresh your memory and my memory, the design brief is that this synthesizer certainly has no ugly row of black and white switches, definitely has no MIDI, and it's not going to have a conventional synthesizer architecture in terms of envelopes, oscillators, LFOs, filters, etc. And it is, we hope, when we get to where we're going to have a bit of attitude. So far we have developed, this isn't going to fit in a whole camera frame, is it? Our turntable to drive the note and our strings to set the pitch, and we've got, there's the electronics, we've got the electronics working. We still need to do a bit on how we transfer the data and what format the data is going to be, etc. So put that on the to-do list. Let's put this down. And in the last video we went round and round and round and thought of sort of strings and bows and carts on hills and of course beer bottles, the vital one. And we did eventually get a very basic sound generation unit working, which is actually nearer an oscillator than what we call an oscillator in a conventional synth, which is just generating a waveform. So the next project we're going to try and actually build a basic instrument using our input, our player input we've developed and our little sound generator developed. And to do that, as we stated, we're using a PC and Windows as just CPU power to do the audio. Costs, it's a lot of cheap power, and well, it's free because I've already got a laptop. What we do eventually I don't know, and it's easy to develop stuff on a PC. So the problem with doing audio on a PC is latency. Windows has never ever intended to be a real-time operating system, so it'll tend to throw things in buffers and forget them while it goes off and does something that Windows considers is vitally important rather than playing your sounds. So standard Windows audio drivers tend to have terrible latency of, half a second or something. So Steinberg, to get over this, came up with the ASIO driver, which is very low latency, which is what I use on Live, Ableton Live. And I thought I would not actually, I could develop this as being a VST plugin within Live, which would probably work okay, but then I don't know, we're somehow beholden to Live and to VST and whatever. So I thought we would rather just drive the audio output of the PC directly for now. What we might do in the future I don't know, but for now, which means using the ASIO driver, which I have never done before. So this video is actually going to be you and I learning how to use the ASIO driver. So let's crack on. Hi there, and I've just hopped out of the triplicate time machine, which will of course feature in later videos, and I have just come from the end of this video, and I realised that there will be those of you out there who don't want to watch me scratching my head for 20 minutes, who just want to get on and get the ASIO working. So for you, if you look in the comments, there's a zip file which contains my modification of their sample code and a little document on the changes I made to get it working. So that should get you going, and for those of you who like watching me struggle with things, watch on. Okay, so googled ASIO SDK and third-party developer support. This is Steinberg's website, or a bit of website that deals with this. Available Steinberg SDKs. Okay, ASIO SDK. It's not actually a file note, so that's downloaded, that's completed. So let us copy that and just drop it on the desktop for now. There it is. Okay, so what's in this zipped up SDK? Let's find out. Hopefully it's in a folder and it's not just gonna throw a million and one files on my desktop. Oh, it is in a folder. So there's the folder. ASIO common driver host, and there is a readme text. I guess probably the first thing to do is grab the PDF and have a look at that. Okay, so this actually looks straightforward, if not exactly up to the minute, because it refers here to preemptive multitasking operating systems such as Mac OS X, Windows 95N/NT. Oh dear, dear, dear. Now, this is not the latest of documents anyway, even if the actual driver's up to the minute. However, so it seems to work on the basis that it gives you a callback function, buffer switch, when it wants some samples, and it has two buffers. One's playing while you're filling the other. So this little table here, the callback sequence is like that, and you fill buffer 0, 1, 0, 1, 0, 1. So that should be fairly easy. And if we look at the function list, it's got an initialization, which you call to set it up, and an exit you call to finish, a start and a stop, like in this. And you can query channels and latencies and buffers and the usual happy stuff that you'd want to know, and create yourself some buffers. And yeah, here we have some callbacks. Buffer switch, I think, is the one that's the important one, that it calls when it wants some more samples. So that should be fairly easy. It tells you about it here, but we'll look at that later. And I also opened up the README document, and if we go down here, we look into driver, ASIO sample. Yeah, there's a Visual C5 project, a Visual Studio 2005 project. Wow, I think I've actually got a copy of that somewhere. I'm sure it won't work, but there you go. But the sample, if you look at these, there's ASIO SMPL.cpp, which is ASIO 2.0 sample driver. So shall we try and set up a project with that? The usual triplicate, stuck it in C manner, and see what we can get to happen. So I got the wrong end of the stick a bit, because I sort of thinking in VST terms, where the host is the, like for instance Ableton Live is a VST host and the Pulsar is a VST plugin, whereas this is the other way around. The host is what we're making and the driver is the code to actually run it. So we actually want host sample. There we go, that's what we want. hostsample.cpp, a simple console app which shows ASIO work, ASIO hosting. Yeah. And here she is. So there's a bit more. Instantiates the driver, gets information for the driver, builds up some audio channels, plays silence for 20 seconds. That sounds like a good starting point, and it's a console thing, so we get down here, and somewhere down here there's a nice main. This is usually the case with Steinberg stuff. So let us set up a project, grab this file, and it's a .h file, and see what we can do, see whether it can compile it. We can compile it. So okay, here it is. So I've got my hostsample.cpp there, and in another folder I've got all the sorted ASIO files that it seems to need to compile. So if I build that, we get a few warnings. Well, get off. We get a few warnings which in the spirit of YouTube channels we will ignore, but it does compile. So if we run it, what happens? We get a black console window for a couple of seconds, and then it bombs out. Okay. I will find out if I can get it to print anything, or at least to stay on the screen for a bit, and bring you back. Okay, so here's the main function, and it calls load ASIO driver and then ASIO init, and doesn't actually print anything out. I don't know whether load ASIO driver won't print anything out. So if either of those functions fails, it isn't going to print anything out. So I've just added a little print to say it's failed, and I've just put a get char in and a done, so it stops when it gets to the end. So shall we fire that up? Load ASIO driver failed. Okay. Well, that now requires ASIO driver name, which is defined at the start of the file there. And we're in Windows. Presumably that's the name of the driver. Now I use something called ASIO for all. So presumably I should try defining that name to that. Okay, so I have changed the driver name to ASIO for all. So shall we see if that works? It will recompile it, I think. Nope, that hasn't worked either. Right, well, I'll do some more investigating. Okay, so digging in the documentation produces a function called getDriverNames, which gives you a list of driver names that you can call, but it actually says somewhere, despite the fact it gives you an array, currently it only supports one driver. Hey ho. And this getDriverNames is part of the audio drivers class, and what creates the audio drivers class object that we want to reference but load ASIO driver. So that gets a little bit confusing. I must say this is typical Steinberg. I found this using the VST SDK. It is sometimes a little confusing and not at all intuitive. So to figure out what was going on here, I went into audio drivers. Right, load audio driver. Okay, so if it doesn't exist, it will create it here, and then it will try and load the one you've specified in the name. But if you don't know the name, well, it should have another version of this function which can load a blank driver anyway. So if we load this and it doesn't recognize the name we've given it, or we've given it a null name, it will return false. So it brings us back to our, wherever it is, a little bit of code here. So it's failed, we know it's failed. However, it has, even though it's failed, it's created ASIO drivers, so we can now use that to ask it for the names, for an array of names, which is what driver names is. And then I've printed out all the drivers in this array, and then it actually says somewhere it can only ever create one, so it's completely pointless having this array. Hey ho. So shall we fire that up and see what happens? Aha, and it's failed because the name is ASIO for all space v2. Right, we're making progress. Okay, so I have updated the name to the one that it gave us, so should we try again? I think we should. Come on. Okay, well, it didn't come up with any errors, but it has done something. Okay, don't know what's going on here. Okay, so I have a solution to the problem after a deal of chasing around. Here is how we were set up before. Up she comes, up she hangs, and in a second, for some reason it's decided to redraw the window on the other monitor. Anyway, it's crashed. However, if we go into 64-bit, there we go, and we hit run again. Yes, break. Ah, it's working, it says. done. Right, we will just get it to play a sound now. I think I'll just throw some sine wave out of the outputs and we'll call it working. Okay, so I have done a lot of fiddling about off camera because you don't want to watch me going why won't it work for several hours, so I will update you at this point. So there are a number of callback functions which you give it at setup time, the ASIO driver that is, specifically two which are used when it has full input buffers for user processes and empty output buffers for you to fill up with new samples. And these are buffer switch time info. You can give it any name of function, this is what they've called them. And this one is called back, it says, when you have new samples and timecode, and whiz down here, and we have buffer switch, which you use when you don't have timecode. And it took me a long time to figure out that though you have to give them the two callbacks to call, it will only, the driver will only call this one or the other one depending on whether it has timecode or not, and it doesn't in this case, and it calls this one, and I put my little code in here to make a noise, to make some sound, without realizing, not very observant, that it actually calls the other callback function here, and the other callback function has all this, and for whatever type of data you're using, it sets memset the buffer to 0. It clears it. So I was filling the buffer with full of nice sound samples, and this bit of code was clearing them. That took me quite some time to figure that out. So now I have simply, well, I've also tidied it up so I can allow it to be downloadable, and if you want to have a look at what I've done, you can have a look at what I've done. It was getting to be a bit of a mess. So I have a make sound function, and I have a triplicate define which adds in all my extra bits of code, and if you take that define out, you can't comment that define out, it's back to what nature and Steinberg intended. So it does that instead of all this stuff. Because I'm only working with one type of driver, I know it's using these, I think, standard 32-bit. Okay, so that took me, what, 3 minutes to tell you and about 2 days to figure out. Hey ho. So here we have my make sound function, just generates a sine wave which alternates every second or so between the left channel and the right channel, just to make a noise. And it's 32 bits, so we're multiplying it by a pretty big scaling factor. And these, the buffers, which live in buffer infos, and there's one of these buffer infos per channel, and for this particular application, channel 0 and channel 1 are the left and right inputs, channel 2 and channel 3 are the left and right outputs, and we're not concerning ourselves with the inputs. So what was I going to say? Oh yeah, the indexes, it's double buffered, it's playing once, buffer out while we're writing to another, so the index is either 0 or 1, and it tells you which one you're supposed to be using. So there we go. Don't think there's anything else I need to tell you. Shall we fire this up? Go on, make a fool of me and don't work this morning, this afternoon, even. Here we go. It thinks about it a bit. There we go. Don't tell me it's not going to work. Oh, here we go. And it's breaking up. Haha. Probably breaking up because I've got Camtasia running and recording, and that takes up a lot of processing power. Anyway, it does work. If I'm not recording, it does work. Yeah. So there we go. We have ASIO ASIO working. Okay, so that's it for this video. That's all I wanted to do, was actually get up and running with ASIO ASIO, or ASIO, running what it's supposed to be called, which we've done, and we know we need to do some more work and try and reduce the latency and find out why it was breaking up all over the place the minute anything else was running. So yeah, on the next one we will try and put that together with our player input and our little sound generator, and see if we can make the basis of an instrument. So yeah, and I've zipped up the code in a little document of what I've done to get it working, in case anybody's interested, and there is a link to that in the description. So that's it for now, and it's goodbye from Triplicate. Goodbye.